would you mind actually defining those hallmarks or just kind of going through those briefly so everybody
Sure.
knows what we're talking about
Yeah.
here?
Yeah. So the Hallmarks of Aging originally were published in 2013 by Dr. Carlos Otin and his team in the journal Aging. And so after that, we had nine hallmarks. And then in 2023, he added three more. So we get a total of 12. So the original nine were genetic instability, telomere attrition, loss of proteostasis, loss of nutrient sensing, regulation. We have mitochondrial dysfunction. We have stem cell exhaustion, and cellular senescence. Okay, so you have those nine. And then 2023 comes along and he adds chronic inflammation, which is like, I think everybody knows that, inflammation drives aging. So it's great. He brought that in as well as autophagy. So autophagy is our cellular cleaning. And in 2016, a researcher by the name of Dr. Otsumi had won the new Nobel Prize in Physiology and Medicine for discovering this cellular cleaning, this autophagy. So very cool that he put that in there. And then the last one is dysbiosis. And we all know that really health starts in the gut. And so how important this hallmark is, of course. But those hallmarks, again, they define that intricate biology, the biological processes of how and why we're aging. And so when you kind of go through them, number one, so genetic instability. So again, our genes, your DNA, beautiful, and we have it for life. That's our blueprint. And it's very susceptible to injury. And the American Aging Federation says that our DNA will is damaged 1 million times per day, right? So that's some issues, but we have a built-in mechanism to help repair it, which is great, but it can only go so far. So we end up with genetic and genomic instability where our genes are they're just not the same from all the insults. And then telomere attrition. So telomeres are those little shoelace caps at the end of our chromosomes, and every time our cells have to divide, they actually will get shorter. And so we're seeing cell stress, or they're just going to hit a limit. And that's that Hayflick limit where they're not replicating, the cell is. And then you look at the telomeres and they're very, very short.